Okay, this is a second attempt at getting the SPI interface on the Microbus connector of the Polarfire Icicle kit to work. Um, Spent the last hour in the previous video um, trying to figure out what to do. Here's a very quick recap. Found the schematics. Schematics has these SPI signals here, connected to these pins here on bank, well, on bank 2. Um, So now we were able to say, okay, those are all in there. We can go in and edit the PDC file. And so we'll show you what we edited here. Um, and I can't, this, so we edited the this file here, Microbus, and we added these signals which did not exist, defining them as 3.3 volts, assigning these these port names to these pin names, assigning the direction, also assigning bank 2 with a VCC of 3.3 volts. Is that really what we wanted? I don't know, bank 1, VCC. Yeah, so I think that should all work. We also copied this file after we edited in the script support area over to the projects area. And so now when we synthesize, it should use this physical design constraint file to define those pins. All right, so remember these names. Copy. And let's just paste it into here. It's a little scratch pad area for me. Um, this is uh, Impress, LibreOffice Impress. Not really too familiar with it, but how bad can it be? Seems okay. All right, so we'll probably end up coming back and referencing these signals. Okay, so now we're going to go to Libero. Okay. So we have a new design. It's a new Verilog design. Um, I created it over in a virtual machine. It's a simulation of it. This is the test bench for it. This is the file itself. Really simple file, like 120 lines. It's got an APB bus interface, and it's just got the clock, chip select, data in and data out signals. Um, so this block here, we're going to add to our Libero. So I've uh, we're going to add it to uh, this project here. Then we're going to put it into FIC1 is the AXI bus. We want the FIC3, which is the APB bus. Um, Again, this is just a stream of conscious video. I have not done this yet. Okay, so we're here. And so what we want to do is we want to go to File. We want to import an HDL source files. HDL stands for Hardware Description Language, which is Verilog or VHDL. Almost always is what it should be. Well, I'm sure that's all these guys support. Um, so left click. This is I pulled in Linky before. This is even a different project that I was doing. So I'm going to do an up arrow, up arrow. It's like up arrow. And I put this into a folder called ICE, for better or worse. I put it into this Verilog examples, which is my GitHub um, uh, repo. I put it into example 4, and I called it. And so this is the name of the analog to digital converter with the SPI interface. I'm going to double click on him, and so that I believe just added it. So now you click on the user HDL, and you can see there it is. Now, the most important thing right now is that you need to click on build hierarchy right here, this little exclamation mark. And just because right now something's going to happen up here where this will get moved up to here after we build hierarchy. But so build hierarchy, can't say it enough. Building design hierarchy. So that was a left click on the build hierarchy button. Let me say it again, build hierarchy. Um, and it's working, working, working. Hey, look at that. Now up in this area, in this work area, it is taken and it's pulled it from just this random collection of source files up into something that it can work with. And now what you can do is you can I just left clicked on it to make it blue. But I don't think you need that. Let me make this guy something else. Here we go. I'm gonna right click on this new block, which is just Verilog source code at the moment. But I'll right click on it and it opens up and it says create core from HDL. That's what we want to do. So let's left click on a create core from HDL. Signals and parameters were automatically extracted. Would you like to remove any parameters or add interfaces? And this one, since we have an APB bus, the answer is yes. So left click on yes. All right. So here are all the ports. It's found these ports. And now what we want to do is go down to this add, edit, interfaces, and left click. And now we go up to add bus interface because we want to add the APB bus interface. So left click. Many interfaces here. All sorts of things. These AXI streams, all sorts of goodies. I'm going to probably play around with these on a different project. But for now, we want to go to APB here, this one. And so I just left clicked on it once. I guess you could probably, I bet you can click on OK. Well, let's do a double click on APB. Double click. Boom. And now what it's doing is it's trying to map my signals to the signals of the APB standard. And so we called it bus interface 1. Let's just call it APB. And stretching for a moment and coming back. So now we've got P adder in the bus definition maps to P adder, the signal I called it. We got this P cell X, and it did not quite figure out that P cell X is the same as P cell. Click on that. Now we got P enable mapped to P enable, P write to P write, PR data to PR data, PW data to PW data, and P ready to P ready, and P slave error. I don't have a P slave error, do I? Do I actually have a P error? Really? I'm so good. Let's see if actually we do have that. Let me go back to my original design here. Scroll up. P error. P error is always 0, which is cool. P ready is always 1, which is cool. Okay, so let's get back to Libero. Where is it? Right here. Just click edit core. Let's click the picture. All right, so P error goes to whatever that is. Now I'm going to click on apply. Oops, change the name back. I wanted to snuck that in there. I wanted to call it APP. Apply. Now it knows the APB, and now we've got it. Close. Everything else is good to know. The extracted parameters we don't need to touch in this case. We press OK. Oh, how's that feel? All right, pretty good. So this is actually getting close. So now, right here in this whole design area here, see, you might end up coming into it and it might look something like this. Um, so what you can always do is hit this recycle button and it will redraw this diagram. It's a little better. Still, you can't see much detail. You can almost see FIC3. That's what we want to work on. So I'm going to do a control, middle wheel scroll, let go, not hitting any keys, middle wheel scroll. And we want to go into scroll. Oh, there's a control scroll again. Now we're here. We want to go into this block. So we want to double click on this block. And that's where we will instantiate our new peripheral. Double click, a single click, double click. Boom. And this is now inside. So they maintain, so Libero has tabs. So this is the tab that we were just in. Since we double clicked, it created a new tab with the sub design of this FIC3 peripherals. And what we got is got this address generation. And we got these other things here. Oh, this is where I put Blinky from my first example. You might be able to look at that if you wanted to for your viewing pleasure. And so what we've got here is we've got so what I'm looking at right now is that they're trying to define the address ranges that like this address generator. He's like decoding the address bus. I need 8 bits of address space for my new block. So 8 bits is I need 2 X's. That's all I need is 2 X's. Is that true? Any one of these will work. Okay, great. So what do we want to get rid of? So we can get rid of this guy, which is this Raspberry Pi I squared C. I don't like I squared C. But all right, so I think he's a victim. Core UART APB. So this is a UART where we could eventually use him. So we could tap into him. Got this 2, which is this I squared C wrapper. So we got 2 I squared C's. We got a I squared C2, C0, I squared C, C0. What was this one? It's a Raspberry Pi ID. Reconfiguration interface. That's something about Raspberry Pi that I don't understand, and I don't think I really care. I think I'm going to go and I'm going to whack this guy. All right, so what I'm going to do is go into here, and I'm going to disconnect. I want to delete. Take that. Huh. So now this guy's just going to be dangling, so the outputs are going to be driven. And that's okay with me. And I put this guy here. I'm going to go to, now we go over to this this pane, window pane. I'm going to left click on my beautiful block, drag it over, holding the left down, release, and there it is. And then what we're going to do is we're going to take it, click, left click, and hold it down. Make sure that's left and hold, I guess. Left and hold it down. And now that's connected, that bus. Let's redraw it now. So I thought redraw would help me, but it's hidden what I'm trying to do. There it is. Scroll in with the control scroll wheel. That's nice. Now what we have, we need a clock. So we take left click on the clock that's you see handy, drag it down. You can see it's creating a line. When you get the plus sign down there, let go. We need a reset. So left click on reset line, go down, click the plus sign, release the left click button. MISO is going to be a primary output. I mean, a primary input coming from our SPI device. So I just right click on it, promote to top level, left click. Boom. See what happened here. Look at that. We got an input pin now called MISO. That's nice, isn't it? And then I'm going to roll. Now then, we've also got RX data. What? RX data? What the? What the? It's RX data. It's a my block. So let's go back to my virtual machine where I was doing work. And I got this guy here, RX data, sure enough. Let's find all occurrences of him. Huh. Yeah, so it's just a floating unneeded input. It doesn't do any harm. So let's just go back to Libero. Ignore him. That's okay. So right click on RX data and let's mark unused. Okay. I guess that was educational. Right click on the Icicle and promote to top level. Right click on CS, promote to top level, and right click on Mosey and promote to top level. Okay, I think we're looking good. Let's rename them to these signals here. MBus SPI clock. MBus SPI clock. So right click, modify rename, and let's capitalize for fun. MBus SPI clock. Okay. Let's click on my notes, MBus SPI clock. The CS, right click, modify rename, MBus SPI CS, and low active. Click on left click OK. Good. Right click Mosey, modify name, double click on the word Mosey, double left click, and MBus underscore SPI underscore MOSI. Okay, let's see if that's the right name. Click on this. Mosey. Great. Okay, back to Libero. And now let's rename that input signal. This one here. Let's see. So you can right click and go to driver. So I right clicked on the signal, go to driver and left click. Takes you right there. And now then right click on the name, modify rename, double click on MISO, Microbus SPI, name in sub out. Okay. Great. This is not bad at all. I think we've just done all the work we needed. Oh my goodness. All right. So now then what we want to do is hit this little redraw. Let's control and scroll in. Do nothing and scroll up and down. Where am I blocking? Oh, here it is. Here's what it's called. All right. So we've got these signals, everything's connected. This is too good to believe. So go to this little trash can with the gear on it. You see it says generate component. Left click on that. So this essentially is converting the schematics into a netlist, Verilog netlist, I believe, somewhere behind the hood. And it didn't take very long. And everything looks good. Maybe not so good. Let's see. Let's get on this bar here. Put the cursor on this like bar here. Left click. Drag it up. We see some warnings. I do say it's successful. Oh, maybe this guy's mad. So let's go up to MPFS Icicle. So left click on this tab to go to the base design. It's here. So you got this little exclamation mark. Right click on the blue box. Update instance with a left click. And now that's been updated. The warning sign went away. And just for good match, oh jeez. So I forgot to connect up to actual pins on this guy. All right. So now, like it should be able to see those here. Got this guy, this signal here. So right click on this signal, the clock signal, promote to top level. Right click on the chip select signal. Left click on promote to the top level. Right click on Mosey spot, the Mosey signal. Left click on promote to top level. Go to here. Right click on MISO. Left click on promote to top level. And let's redraw, which is this. Says what? Reset layout. I call it redraw. Left click. All right. And now then, if we go to here, we've got these signals here. And kind of pretty straight out. Huh? So we've got our clock, CS, and Mosey. And if we click on this one, we got this guy. So those are our four input-output signals. This is in here. Did I hit on the can yet? I never heard. Oh, so you got the star here, so it usually means that you need to regenerate. So left click on this yellow can with the gear on it. You got a flower. It's probably a gear, but left click on it. And it says successfully regenerated. And so we are good to go. I don't like exclamation marks, so let's click on build hierarchy again. I don't think we need to do this. Left click on build hierarchy. Let's think for a little bit, not too long. And we are one step away from starting to try to synthesize this into gates and then place and route those gates and then create a bit file and then put it onto the Icicle using Flash Pro and then running it and probing the SPI signals to see that they're wiggling. Nerve-wracking. Here we go. So so we've got a lot of tabs down in here, which we were just in the design hierarchy tab. Let's click on the design flow tab. And let's go down to Goblin Town. No, let's go to generate bitstream. And so it's going to do a lot of things here. It's going to take probably 20, 30 minutes to generate bitstream. So that's okay. I'm going to double click on generate bitstream. See all these warning signs? That means that all of that stuff has been changed and work needs to be done on it. And so it's going to flow through all those steps to eventually generate a bitstream if all goes well. So it's a double left click on generate bitstream. Here we go. Double tap. So fingers crossed. Hopefully this builds. Hopefully, and then the next thing you'll be hearing from me is that it worked or didn't work on the Icicle kit. Okay, fingers crossed. Good luck. I think that's about we've got for now. Shift print screen.